Now you might ask, what in the world is a quadratic expression? Well, a quadratic expression is any trinomial that has a special form, ax squared plus bx plus c. Now the variable is totally arbitrary, so we could have something like 2r squared minus 3r plus 1. This is a quadratic expression in the variable r. And of course you might see other variables as well, but usually a, b, and c are going to be integers. I want to begin by looking at the special case x squared plus bx plus c. Notice that in this case, a is equal to 1. These are usually the simplest cases to factor. I want to work through an example so you can see why we're factoring the way that we are. So here I have x plus 6 times x plus 2. And if we distribute the x plus 6 to x and the x plus 6 to 2, we can use the distributive property one more time to get x squared plus 6x and 2x plus 12. And of course, if we want to simplify this expression, we can collect together our two like terms here in the middle to get 8x. And this would be our final expanded form of this particular product. So what we want to think about is, how do the numbers over here, the numbers b and c, relate to the terms inside of our factored form? That is, we might ask the question, how are 6 and 2 related to the number 8? And how are 6 and 2 related to the number 12? Well, we can see easily here that if we were to multiply the values of 6 and 2 together, that'll give us 12. And if we were to add together the values of 6 and 2, that gives us 8. So what I'm trying to do is show you a strategy if you're given a trinomial that looks like this, and we want to figure out how to factor it. What we do is we look for two numbers that add together to give the middle term of 8, and two numbers that multiply together to give us our last term of 12. So if we can find these two values that add together to give us 8, and multiply together to give us 12, then these are the two values that we use inside our fully factored form. So just to summarize what we saw on the last page, if we're trying to factor x squared plus bx plus c, we're looking for two numbers p and q that satisfy p times q is equal to c, which is the last term. P plus q is equal to b, which is the coefficient of our middle term. Now, big piece of advice. This strategy only works for the form x squared plus bx plus c. If there's a leading number in front of the x squared, there's an entirely different strategy we have to use, and that's going to come up in the next two lessons. The second thing is, once you do find the numbers p and q that satisfy the two properties, you're going to factor your quadratic expression into x plus p times x plus q. Let's see this process in action. What I'm going to do in blue is I am going to write down our two values, 21 and negative 100. 21 is the coefficient of our middle term, and negative 100 is our last term. So remember that we're looking for two values. I'm going to call them p and q that sum together to give us the coefficient of the middle term. P and q also have to multiply together to give us negative 100, our final term. Can you see what the values of p and q could be? Well, what happens if we take p is equal to 25? Well, we could take 25 and multiply by minus 4 to get negative 100. Also, we have that 25 minus 4 is equal to 21. So these are the two values that we're going to work with when we're factoring our trinomial. I'm going to go back up top. We're going to create two braces, and P goes first, so x plus 25, and then Q goes second, x minus 4. In this example, the two numbers that we're going to be working with are 12 and 27. Remember that we're looking for two numbers. Since we already have the variable p here, we might say a plus b. A plus b have to add to the coefficient of our middle term, which is 12, and a times b must be equal to 27. In this case, the numbers are small enough that we can probably scan through our multiplication facts and try to find two numbers that multiply together to give us 27. Those numbers are 3 and 9. And then we could just double check that 3 plus 9 is equal to 12, which it is, and voila, we have our values for a and b. This means that if we would like to factor this quadratic expression, we're going to get p plus 3 and p plus 9. All right, my little epsilons, stay positive.